AP Chemisters, this is Mrs. Blankwalle bringing you 14.9 part 2. We left off, and I was in a huge hurry when I was trying to finish this last one. I saw my time was being used up here. So I'm going to redo letter D real fast, okay? So explain and describe the change that the system will undergo if water is evaporated. So water is a reactant. So if I do Q is equal to P over R, R is what? Going away, so R goes down. What happens to Q? Q now is greater than K, and so how will the system react? Now it's too big. I have to make that number smaller, so I'm going to lose the products to make up for the lack of reactant. So it's going to shift to the left. And what color does shifting to the left make? Blue. That's why I switched colors again. So there you go. We actually finished that problem, and I apologize for being in such a hurry with the last problem. So let's go ahead and see what the next page is. Okay, so we've completed the first stress that Le Chatelier said could happen, and that was a change in concentration. This is the another stress that could be added to change the equilibrium, and that will be pressure. So how can I change pressure? Well, I can add or remove the gaseous reactant or product. I can add an inert gas. What does an inert gas mean? Inert means that it's like it doesn't react. So think of our noble gases. Okay, our noble gases would be an inert gas. They don't react. Okay, now read carefully what number 2 says. An inert gas will increase the total pressure, but has no effect on the concentrations of the partial pressures of the reactants or products. Now think about that. It has no effect on the concentrations or the partial pressures of the reactants or products. Okay, that's important. Most commonly, you can change the volume. So as we know from our gas laws that it's an indirect relationship, so if V goes up, P goes down, right? Or vice versa. So if V goes down, P goes up. Okay, so what's going to happen here? Here's our example, and this is the Haber process. Remember I told you about making ammonia, very, very typical one here. So what would be the result if neon were added? We'll go back. What is neon? Oh, is neon a noble gas? So what did I say about noble gases? Noble gases are not involved in the reaction, and neon is not. So an inert gas will increase the total pressure, but has no effect on the concentrations or partial pressures. So if Q is equal to ammonia raised to the second over nitrogen and hydrogen raised to the third, what if nothing changed? What if the partial pressures or the concentrations did not change? What will Q do? If it's at equilibrium, I add neon, will Q change? No, Q is not going to change, so Q is still equal to K because nothing here changed, therefore there won't be any change here. So what would be the result? Nothing, honey. All right. What about the next one? What if I'm going to erase some of this so I can read it. Hopefully you already wrote that down. If not, go back. All right, so what would be the result if the volume went down? So volume goes down, pressure goes up. Okay, so volume goes down, pressure goes up. Now, how do I deal with that? This is this number 3 right here. Okay, you need to look at your reaction, and you need to look at your number of gas molecules on both sides. Okay, so if I were to add these up, there's 1 nitrogen and 3 hydrogens. That's 4 molecules of gas. Here there's 2 molecules of gas. So if pressure goes up, well, I want to go back a couple pages. What did I want you to think about Le Chatelier? Okay, so it's going to have what kind of effect? It's going to do what? The system will shift in a direction that minimizes the disturbance. Okay, let's go back to our problem now. Here it is. So if I have 4 molecules of gas on the reactant side and 2 on the product side, and I add more pressure by decreasing the volume, which side is going to be most affected? The one with 4 molecules or the side with 2 molecules? Well, the side with 4 is going to be more affected. They're going to feel that additional pressure more than the 2 will. So it's going to decrease or minimize that disturbance, and it's going to shift to the side of fewer molecules. So this one is going to shift to the right to make more products, okay, because that's the side with fewer gas molecules. So what about the next one? What if the volume goes up, pressure goes down? It's going to be the opposite. So if it's going to shift to the right with more pressure, it's going to shift to the left with less pressure. So it's going to go towards the side with 4 molecules to relieve its stress, if you will. Okay, so it's the opposite. So if you're counting molecules, then you're going to, if you increase pressure, go to the side that has fewer molecules. Now here's a good question. What if you have a balanced equation of the same number of gaseous molecules on both sides? Then there'll be no change if you change the pressure. So let's look at this one. Consider the following reaction. What do you see here and what do you see here? Always look, because that's going to change the answers potentially. So what's the effect of decreasing the volume of the reaction mixture? So if volume goes down, pressure goes up. Well, which side has the most number of gas molecules? This side has 3, this side has no gas molecules. So if I increase the pressure, how will it shift? Hopefully you said to the left. Okay, that's where I have fewer gas molecules. What if volume goes up? Pressure goes down. Okay, so what's going to happen there? It's going to shift to the right. It's the opposite. And same question as before. What if I add an inert gas? Nothing. Okay, nothing's going to happen. So it's not going to shift either way. Okay, let's go to the next page. Okie dokie, so problem number 34. Why don't you go ahead and read the question and figure out which one is going to be true if more oxygen were added. Did you pause this? All right, so if oxygen goes up, what's going to happen? It's going to shift to the right, so that's letter C. If you look at everything else, more ammonia will be produced? No. If it shifts to the right, I'm going to have less ammonia. More oxygen will be produced? No. I'm going to use up the stuff I just got. If it's going to shift to the right, then D is wrong, and yes, something's going to happen. So C is the only answer. All right, so I want you to do number 2. Read it, pause, and then wait for me to come back. All right, how'd you do? Well, I'm going to erase this, and this is where if pressure is changing, you need to count. So how many gas molecules are on the left-hand side? Well, 4 plus 5 make 9. Sorry about that. And how many are on the right-hand side? I see 10. So if pressure goes down, well, okay, let me think of this way. If it goes up, it's going to shift towards the 9. So if the pressure would decrease, it's going to shift towards the 10. So A is not right. More oxygen would be produced. No. If I'm shifting to the right, I'm going away from the oxygen. No. The water vapor would become liquid water. I don't know about that. That's kind of weird. It has nothing to do with this. The ammonia concentration would increase. Not if it shifts right, it doesn't. It's going to decrease. And the NO concentration would go up. Yes, that's your answer. If it shifts to the right, NO will increase. Okay. Well, let's look at problem number 35. Let me write down the equation for you so you can ask the question then. All right. So we have NOBR makes NO plus Br2. So I need to balance it. And guess what? They're all gases. Now that you know that, go ahead and answer question number 35. All right, so what did you say here? Hopefully you paused it. what's going on here? You increase the volume, so the volume went up. So pressure's going down. Now, real quick, it says the temperature is held constant. A and B are already gone, okay? The only thing that is going to change the K values is temperature. So A and B are wrong if you have the constant temperature. So now we're going to shift to the right, shift to the left. So this is where you have to count again. So here I have 2 molecules of gas. I have 2 plus 1, 3 molecules of gas. So if pressure were to go up, it would go towards the 2. If pressure goes down, it's going to go towards the 3. So it's going to shift right. Okay, and that is answer, looks like answer C. Okay, and there you go. That's not too bad, is it? Let's see the next one. Okay, so here is the third stress that Le Chatelier was talking about. And it is a change in temperature. And this is the only stress that will actually change your equilibrium constant. So an increase in temperature increases the energy of the system. Le Chatelier will predict the system will shift in the direction that consumes the energy. A decrease in temperature will cause a shift to replace that lost energy. Folks, this is the same thought as if heat were a chemical, all right? So if heat is on the product side and you add heat, it's going to shift this way, left. Okay? What about the equilibrium constant? So if it shifts to the left, products goes down, reactants goes up. What happens to that value? Okay, what happens to the value? It's going to go down, so K will decrease, okay? What about the other way? If I remove heat, all right, it's going to shift to the right, and so if it's still products over reactants, products increases, reactants decreases, what happens to my K value? It's going to get bigger. Okay, so I'm going to increase that value. That's a really important idea, so make sure you understand this. This makes sense to you. But endothermic reaction, notice where the heat is for an endothermic reaction. So if you add heat, it's going to shift right. So then products over reactants, so I make more products and less reactants, K increases. What if I remove heat? It's going to shift left. So, oops, I can't spell left. There we go. So it's products over reactants. What happens here? Products goes down, reactants goes up, so K will go down. So I'm hoping that you understand this idea of these proportions, what happens when you increase and decrease your numerator and your denominator, what happens to the total value. If you're still struggling, just plug in some numbers, all right? See what happens if the denominator goes from a 2 to a 5, all right? Make sure that makes sense to you, okay? Let's see what the next page holds. Okie dokies. So cobalt chloride, it is the same experiment we already talked about before, but what has been added? We now know if it's endo or exo. So if delta H is negative, what do we know? Heat is a product. Okay, because it's did I say endo? Because it's exo, heat is a product. So what happens if temperature goes up? If this goes up, how is it going to shift? To the left. If it shifts to the left, what does that mean? Well, products goes down, reactants goes up. What happens to K? Goes down. What happens to the color? Turns blue. Should have used the other color. Okay, what if temperature goes down? Can you figure out what happens? Look at everything I wrote and do the opposite. This is to the right, K goes up, and it turns pink. Okay, hopefully that makes sense to you. How about number 37? Why don't you go ahead and do that. Pause this and see what you get. Okay, well, I'm just going to have a hypothetical situation here. A equals B, or yields B. So the first case, K is 1.2 times 10 to the negative third. Second case, K is, something to the negative first. Isn't it 3.4 to the negative first? What happened to K? It's a first. K increased, right? K went up, didn't it? So if the temperature goes up, K goes up, What is it? Well, look up above. Which one is it? So if here we go. K goes up, temperature goes up. It is endothermic. Hopefully that makes sense to you. We got one more of these blank walls. Stay tuned. Don't wait to be great.